In this video, we're going to learn how to solve three variable systems by elimination. Now, what I mean by a three variable system is now instead of just x and y, we'll also have a z variable we need to solve for as well. And our answer will end up being an ordered triple rather than an ordered pair. Now, for the sake of keeping track of steps, I'm going to label these equations 1, 2, 3, so you'll know when I'm using which equations and when. Now, the first step to solving these three variable systems by elimination is by pairing the equations to eliminate y. And we're going to have to find two different pairs to eliminate one of the variables. Now I'm choosing y because I can see here that there's lots of opposite y values, which will make it perfect for elimination. So I'll start with 1 and 2. Equation 1 being x minus y plus z is equal to -1. And equation 2, which is x plus y plus 3z is equal to -3. And by adding these equations together, I'll get 2x plus 4z is equal to -4, which I'm going to call equation 4. So I know that this is a different equivalent equation for the system just by adding two of them together. Now, I want to combine equations 2 and 3 as well, because again, those are also opposite in value for the y's, so the y's will eliminate each other. We'll have x plus y plus 3z is equal to -3, and 2x minus y plus 2z is equal to 0. Again, adding these together, I get 3x plus 5z is equal to -3, and I'll call this equation 5 since it's a newer one. Now, these two new equations I can write into their own system. So for equations 4 and 5, I'll have 2x plus 4z equals -4, and 3x plus 5z is equal to -3. And now that they're in a two variable system, we have strategies for this as well, which I'm going to use elimination to solve. But we just need to find the values of x and z, and then we'll go back and find the value of y afterwards. So, making a new system to set up for elimination, I'm going to try to eliminate x, since they're common multiples on the shorter end, on the smaller end. So I'll take equation 4, multiply it by 3 to get a positive 6x, and take equation 5 and multiply it by -2 to get a -6x. So I can eliminate the x variable as well. So my new system will look like 6x plus 4z times 3, which is 12z, is equal to -4 times 3, which is -12. And then -2 times 3x is -6x. -2 times 5z is -10z. And -2 times 3 is 6. So now when I combine these together, the x's will cancel, and end up with 2z is equal to -6, which I can solve z to be equal to -3. So that's one solution down. And now I can go back and find the x variable. I'll plug in -3 into either one of these equations. I'm going to use the first equation. So 2x plus 4 times -3 is equal to -4. This gives me 2x minus 12 is equal to -4. Adding 12, I get 2x is equal to 8. So x is equal to 4. And now that I have what x and z are equal to for -3, I can solve for y, which means I'm just going to go back to any of the original equations. I'm just going to use the first one, x minus y plus z equals -1, and plug in x and z, 4 for x, -3 for z, and I'll get 4 plus -3, which is 1. So I'll have -y plus 1 is equal to -1. Continuing forward, I would subtract 1, get -y is equal to -2, y is equal to 2. And now I can write my answer as an ordered triple starting with x. So 4y 2 comma negative 3. Now, if I wanted to check my solution, doesn't take too long, just go back and plug all three of these into every one of these equations that you started with and make sure it's correct. I'll check two of them just so you can see. 4 minus 2 is 2, plus negative 3 is negative 1. 4 plus 2 is 6, plus 3 times negative 3, so that'll be 6 plus negative 9, which is negative 3. And just for the bonus of it, if I plugged it into here, 2 times 4 is 8, minus 2 is 6, plus 2 times negative 3, which is plus negative 6, which would give me 0. And that's just the way you can check your solution when you're done, just like with two variable systems. Now let's try one more example. I'm going to look at this system, but right away you don't see anything that cancels out just by combining two of them, except maybe the first and last equation. But I'm going to go ahead and still cancel out my y's to show you that path. So again, if I wanted to cancel out y and with the first and second equation, I would need to multiply one of these by negative 1. So when I add them, the y's will cancel. So I'm going to take equation 1, multiply it by negative 1, and now I'll have a system. I'll keep 2 the same. Negative x minus y minus 2z is equal to negative 3, and 2x plus y, keeping the second one the same, is equal to 7. Adding these together, I'll get x plus z is equal to 4. I'll call that equation 4. And again, I'll do the same thing. I'm looking at these two here. I want to cancel out the y's. So the second equation, I'm going to multiply by 2. I'll keep the third one the same. And the reason why is 2 times y is 2y, and I'll cancel out the negative 2y. So I'll have 4x plus 2y plus 6z is equal to 14 by multiplying everything by 2 and keeping my third equation the same. I'll have negative x minus 2y plus z is equal to 10. Adding together, I'll get the equation 3x plus 7z is equal to 24. Now again, my next step would be to create a system using these two new equations. So using 4 and 5, of x plus z is equal to 4, and 3x plus 7z is equal to 24. Now, I used elimination last time in step 2, but we've already eliminated. We got down to a two-variable system. Now, we can solve this one using any method we like. And I'm seeing here that I have x and z with no coefficients, so this could be a perfect time to use substitution. So again, taking my fourth equation and solving for x, I can get x is equal to 4 minus z, and I can substitute that into my fifth equation, which will be 3x plus 7z is equal to 24. So this now will be 3 times 4 minus z plus 7z is equal to 24. Distribute the 3. We have 12 minus 3z plus 7z is equal to 24. Subtract 12. Add the z's together. We get 4z is equal to 12. Divide by 4. We get z is equal to 3. And now I can go back and find x. I'll use the first equation. X plus z equals 4, which will now be x plus 3 equals 4, which means x is equal to 1. And now you have x and z. I can substitute that into any one of the original equations. I'll use the first equation, which will be x plus y plus 2z equals 3. Now I'll have 1 plus y plus 2 times 3 is equal to 3. So I have y plus 1 plus 6, which is 7, is equal to 3. Y is going to be equal to negative 4. And our final solution will be 1, comma, -4, comma, 3. Now will be the solution to the system. And that is how you solve 3 variable systems by elimination.